Continuation of yesterday, we're combining inequalities now though. So instead of having an inequality like 2x is less than 7, we're going to have one with several parts along. So not just one part, but several parts. So let's take a quick look here. We're going to start with the word conjunction, and then we're going to look at the word disjunction. And they're just fancy ways of saying other stuff. So a conjunction is a statement that gives pretty much a range of values that the variable can take on. So the statement, for example, here says that x is greater than a, but x is less than b. So it's between a and b. Again, logically think about it. Start in your mind here, picture it. X is greater than this value, which is a, but it's less than this value over here, which is b, which is a continuum or range of values. So this, although written here as x is greater than a and x is less than b, can be written simply this way. Here's how this is read. This here is read that x is greater than a and less than b, but you could also say that x is between the endpoints a and b. X is between the endpoints a and b. So this is a conjunction where the range of values for x is from a min to a max. A disjunction tells us that x is greater than something. Let me put it on a number line so you can see. This is a. It tells us that x is greater than a or x is less than b. Whereas up here, this would have looked like x is greater than a and x is less than b. So look at the differences here. Okay, for x to be greater than a or less than b, a and b are in opposite spots. Notice the differences? These are solutions that are drawn outward. A disjunction, an or statement, is a solution that starts here and can be this range or this range. A conjunction, the and statement, is when it starts here and it ends here being only one range of values. So we're going to see these examples in a minute that will help us to understand what we're doing. So let's look at the first one and see how this works. So the first one is a conjunction right away. I know it's a conjunction simply because of the way that it's actually written here. I have x and it's between two values. The problem I have, though, is that x is not by itself, right? So I think of this as like a three-part equation. Like equations have a left-hand side and a right-hand side. This has three sides. It's got a middle and a right and a left. So I can break this into two pieces if I want to, or I can just operate on all three parts at the same time. So I'm going to start by operating on all three parts, and then I'll show how to break it up. So if I want to get rid of what's near x, what do I get rid of first? If this were algebra, regular algebra, what do I get rid of near x first, Maura? Subtract 3 on all three parts. So subtract 3 from all three parts. I agree. And that's what I mean by operating on all three parts. And then how would I get x by itself? How do I get rid of that negative sign there? What do I do?
Divide by -1.
And Isabella, when I divide by -1, what do I have to remember to do?
Change the sign.
Good. So this becomes 5, flip the sign. This becomes x, flip the sign. This becomes -1. So although this is not written in the traditional way we would see an and statement, it is an and statement because x is between those values. Which is the lower value? Obviously, which is the lower value? Yeah, so we're really starting at -1. So I'm going to write my answer like this. And then I'm going to say this, and then this. Can you inspect and see that those are the same things? The answer in red is the same as the answer in blue. I've literally reordered it and just switched the order of my signs, or the direction rather, of my signs. So the less than came from the greater than. The less than or equal to came from the greater than or equal to. So you literally just need to read this backwards. Okay, just read it backwards when it's written the other way. So how would I represent this answer on a number line? How would I show this on a number line? Regina, what do you think?
Well, you label the number line with -1, 0,
Okay? And I don't even need the 0. I'm going to leave it because it doesn't matter. With the 1 number, we could use a 0. Keep going.
And you put an open circle in 1, a closed circle in 5. And you shade the area between.
So again, x, here's how I read this. X is between -1 and 5, including 5. Again, x is between -1 and 5, including 5. Hence, closed circle at 5. How would I write this answer in interval notation? From yesterday's class, from interval notation. What would I write from interval notation? Just Morrow? Is anyone that remembers this from yesterday? You just answered too, sorry. Come on, somebody else. From interval notation, yesterday's class, what should interval notation look like here? Open circle. How did we show an open circle with interval notation? Parentheses.
Closed would be a bracket.
Very good. Well done. Okay, there's my range of values, or my interval of the solution. Please write yourself a note. This is called set notation. We wrote it yesterday. This is interval notation. Any questions on the first one? All right, let's press on. Let's go right into example 2. Actually, I didn't break it up. Does anybody feel uncomfortable with this method? Because what I can do is we can take the original and break it into 2 statements and then solve them separately instead of solving them all at once like we did. I think it's faster to do it all at once. Can we just stick with this? Is this okay? I think it's a faster method. It is a faster method, so I'd rather do it. An or statement, though, we have to do them separately, right? Because a conjunction, the previous one, an and statement, you actually see 3 terms. Here, it's separated by the word or. So you have to actually proceed separately. So go ahead and proceed separately and solve these both. Should be done at this point. Okay, this is not a difficult problem at all. I mean, at least up to here. And if you got to this point, check your work, and then please plot it on a number line. You have your solution. It's literally written there with the word or in between. Plot it on a number line, and then give the answer in interval notation. I'll talk about that symbol in a moment. I introduced a new symbol just now, so I'll show you in a moment. And you can probably guess what that symbol means, obviously. So look at your number line, check to see that it's correct. If I were to make the statement that C is less than -3 or it's greater than 6, it can't be both, right? Is that possible for this to be true for both? Can a number be less than -3 and at the same time more than 6? So if you wrote the word and accidentally, it doesn't make sense, right? Logically, a number, remember, what is an and statement really? An and statement is an overlap of 2 sets. It's where those 2 sets are merging. An or statement is not. An or statement is saying the solution is in this region or it's in this region. So what do you think this symbol here means? Or. Just use context, right? So C less than -3 is from -infinity to -3. Both parentheses, is open circle. Infinity always gets parentheses, always. Or from 6 to infinity. What's the word I would say that tells me that both 6 and -3, infinity, are all not included? What would I say? What's the word? The word for it. It means something totally different in like the world of like pop culture. Exclusively? So I could say that the solution says that from negative infinity to negative 3, or 6 to infinity exclusively, meaning excluding the endpoints. Excluding the endpoints. Inclusively is a way of saying that all the endpoints are shaded, or brackets. Again, exclusively is a vocabulary word meaning that it is a less than or a greater than symbol. But if it were a less than or equal to, or a greater than or equal to, we would use the word inclusively.
Does it matter how you place negative infinity and negative 3 and 6 and negative 3?
You should do it in order from least to greatest. So you should do it this way. Technically, it's not incorrect. Will I give you a hard time? Absolutely. Because this is not logical, right? But yeah, it doesn't matter really. Okay? You could technically change the orders and stuff and it would still be true. Depending on how you changed it though. So just do it in order, make it easy for everybody. Let's try another one. In the next one here, we're going to see that we have the word and written. So we don't have a conjunction in the middle, but we literally have the word and the word is written in front of us. Guys, focus on notes, not other stuff. The word and is in the middle. So I need to first start by progressing through these two things separately. I'm going to do them separately because they're separated. I don't have a conjunction in the middle there, so I'm going to actually address them separately. Please notice something. There's no need to distribute the negatives on the outside. Just divide by negative 1 in both cases. Start both equations by dividing by negative 1 and flipping those signs right away. And then progress through. It makes it a little bit easier. It's the same thing, really, honestly, right? You can distribute first if you really want to. What do you think here? Anybody got any idea? I stopped for a reason so you guys could look at this and kind of inspect. Regina, what's your thought?
They are going to overlap, so say less than negative 3. I didn't know that much.
Well, look at the numbers we have up here. It's fine.
So there's no solution.
There is a solution. Be careful. What does an and statement mean? Both of these things have to be true when it says and, right?
So k is less than negative 3. That's the answer because k is less than 5 is the eaves into the other.
Can we describe it graphically to help a little? So k is less than negative 3. That looks like this. Visualize, okay? K is less than 5, negative 3. K is less than 5 looks like this. But an and, good.
And then from negative 3 to the left is the answer.
Because that's where
Because that's where they overlap.
the overlap is the answer for an and statement. Just like earlier, if I said that a number is greater than 2 and less than 5, let me put this up here because we didn't actually show this. A number greater than 2 looks like this. A number less than 5 looks like this. Take a look over here first, and that helps. So when a number is greater than 2 and it's less than 5, it's between 2 and 5, right? And where do they overlap? Between 2 and 5. So greater than 2 is the bottom, less than 5 is here. From there to there is the overlap. Open circle dictates for both. So here, we want to know when the number k is less than negative 3 and when it's less than negative 5. That only occurs for all numbers less than negative 3. So my answer is in green here. My answer is in green there. So this would be my answer. So in set notation is given. In interval notation would be this. Okay, interval notation at the very bottom. Set notation, the answer is k is less than negative 3. Because that's where the overlap is occurring. This is the interval notation answer. So for an and statement, write yourself a little note, please. An and statement looks for where the answers overlap. For an and statement, it's a question of where do the answers, or number lines, I should say, right? The number lines themselves, where do they overlap? Questions? I'm trying to step you through different types of questions, right? So you notice the first one was and, the second was or. This was and with a little bit of a funkiness to it, right? Where you have both and statements in the same direction and they only partially overlap each other. So let's look at the next one that's going to be just the same. Previous example you're talking about, right?
Yeah.
It could have been written for set notation as this. Okay? Your book uses a colon here. I think in your newer books they would use a vertical bar, right? It's the same thing. The colon, K is in the set of the numbers where K are less than -3. Okay, that's just another way of writing the set notation with the squiggly brackets. Yeah, and more complicated. So we've got this or statement here. By the way, what do I do with the right inequality to make it easier? The inequality on the right side. What should I do to make it easier? Yeah, multiply both sides by 10 to start. So I'd write this as f plus 5 greater than or equal to 0. So multiply by 10 on both sides before you even begin anything. We know we can do that because we're multiplying by a positive. We don't have to flip the sign there. So that becomes the equation on the right, which then solved simply becomes this. Yeah, the one on the left, we're going to move the 1 over. We get 2f less than -10, and then f would be less than -5. So what's the deal here? What's the deal? The solution tells me that f can be less than -5, or it can be greater than or equal to -5. What numbers are less than -5, or they can be greater than or equal to -5? All numbers are. I agree. And how would I see that? I put -5 as my point. Less than looks like this. I'll shade it in blue. Greater than or equal to, I'll shade in red. And inherently, what am I shading? The whole number line. Again, in blue is an open circle right here. There's an open circle in blue, shading to the left. In red, it's a closed circle, shaded to the right. And inherently, I'm shading everything then. So this answer is all real numbers. That's set notation. And then in interval notation, how do I write an interval notation?
Close bracket, negative infinity, comma infinity.
Yeah, parentheses, not bracket, parentheses. Remember, infinity always use parentheses, even though we have a closed circle here, okay? Because infinity is the endpoint you can't get to. So we have set and interval notation, both representing all real numbers. What's potential?
What is the E here?
Remember, this means f is in the set of real numbers. Real number set, you put a double slash for the r. That's this extra thing here. See how it's like 2 vertical slashes for the r? It's like a bolded r is the set of real numbers. This is an old notation of writing, but your book uses that still too, and it is used today on like subject tests and AP calculus. So it's good to know that notation.
Would
Yeah.
it be possible to write it like this? I mean, this is the example above, but kind of like that.
Yeah, this is also set notation. So another way of writing set notation. But I do want to get this next one. Okay, if we will finish this, yeah. We're going to finish in about 2 minutes. But I also asked you to look at one of the homework problems from the other night. Remember the last example from class yesterday? So I want to discuss that too. Let's solve this one and see what we get. All right, there's my answer already, right? I've got it. It's right there. X is greater than 11. That looks like this on the right, and X is less than 2 on the left. What's the issue, though, with this problem? What's the problem with this problem, Julia?
It says and, not
It says and, not or. If it said or, that's done, right? But and means we have to find where they what?
Overlap?
Do they overlap?
No.
So what's the answer?
No solution.
No solution. So these do not overlap. So there is no solution set, empty set, null set, whatever you want to call it, okay? No solution to this last one here at all because of the fact that they don't overlap. There's no number that is greater than 11 and a number that is less than 2. Your homework is written on the next slide, but I'm going to address the last question from yesterday. Can somebody go to the notes, please, quickly? Go to the 2-1 notes. More, read it for us, nice and loud, the last example. Not the homework, but the one from class.
Why is the following statement true? If a is greater than 0 and a is less than 1, then a squared is less than a.
So here's our statement that was made. Let's take a quick look. We're told that if a is greater than 0 and less than 1, which is this first part, why is this statement true? And this is using inequalities. But this is something that's, I swear, on every SAT. They use notation, but the minute you use numbers, it makes it a lot easier. Regina, what do you think?
Because say it's 0.5 squared, it would become 0.25, just smaller.
Because you're squaring a...
Fraction.
Yeah, whenever you square a fraction, any fraction between 0 and 1, the overall value decreases. When you square any number besides a fraction, the value increases. But when it's a fraction between 0 and 1, because you're going to have improper fractions. When you square any fraction between 0 and 1, the value decreases. So when you're thinking about this on your SATs, I'm telling you, it's one of those questions that always shows up. And I kind of threw it in there because it has to do with inequalities, right? So this weekend, what are you doing? Homework and then emailing me. If you want to, what else could you do? It'd be a little bit proactive. Problem set starting point. Okay, keep that in mind for next week. Tuesday, we do 2-3. Wednesday, PSAT. Thursday, review. Friday, test.
Is the chapter 2
Oh, chapter 2, you need the electronic version, right? I'll put it in your folder in like 2 minutes. I'll drop it into your once you open it though in iBooks, delete it out of your folder again. I'll put chapter 2 in there in like 2 minutes, okay?